It actually bothered me a lot that Brody didn't agree with our shifting. It bothered me quite a bit, especially because I think I know what he was seeing and why it was bugging him. And it just doesn't work. That's all I can tell you. It just doesn't work. I think I see why he was saying that it was a shift up of 3. So I went and got a fresh sheet of paper, and here's mom. And if you reflect mom, you get this. And this point shifts down here. All right? That's where that point shifts to. And you kind of looking at it, it looks to me like it was a up 3. If you look at it like this, it goes up 3 and back 4. Well, that's entirely opposite of what we wrote here. Or sorry, it goes back 3 and up 3. So I think maybe that's why Brody was thinking the shift was only 3. But my main reason was just kind of thinking, I was just trying to make sure this was a valid point, and it for sure is. This is a valid point, 4-2. And I guess what I'll try to do so y'all don't have any confusion is I'll plot the points you should use. That way there's no confusion on what you should use, right? Because heck, if you're half as tired Monday as I am, it's not going to be good. We had settled on this. We had settled on f of x is, I guess that it's a negative a. I don't think it matters, but it's a log of x plus 3 plus 4. If we do our math right, a will work its way out, right? It should. So everywhere I see f of x, I'm 2, and that was a base 7, by the way. Everywhere I see an x, I'm a 4. I'm going to take away the 4, get my negative 2, and I'd have a log base 7 of 7, which is 1, so my a value is negative 2. Now, if you got any questions on whether what you write or not is, whether what you write is right, go to y equals and type the thing in. And you can check your table out real quick, and you'll see that we do contain that point negative 2, 4, which we identified. And obviously, because we used it, we contain the point 4.2, which this graph is highly suggestive that we do. I'm sure there's some other points in here too. I don't know of any good ones that I can use. I just don't see anything. But anyways, it was, I think I understand now why Brody was thrown off. It's hard to do shifts and transformations in your head. It really is. Here's number 12. The half-life of palladium 100 is 4 days. After 20 days, a sample of palladium 100 has been reduced to a mass of 2 milligrams. What is the initial mass? And again, I could care less which form you use. If you want to use PERT, use PERT. If you want to use principal times 1 plus R, sorry, this is half-life, isn't it? If you want to use principal is 1/2 times the T over half-life, by all means use it. If you use PERT, it's a longer process. It really is a longer process. If you use PERT, R is the natural log of 1/2 over the half-life time. But, they don't, which they tell you. You can use PERT if you remember this. If you don't remember that, use this. Because I have a hunch you remember that. That's what I'm going to do when I instruct. All right, so after 20 days, we have 2 milligrams. We started with 100. Oh, sorry, we have no idea what we started with, do we? 2 is the principal times 1/2 to the time, which was 20 days, over the half-life time of 4. So 2 is the principal times 1/2 to the 5th power, which would be a 32nd. Anyways, 32 both sides, and 64 is your principal. From what I saw of those of you doing this in class, none of you are having any issues with that. And now I actually have an equation. The amount after time passes is my principal amount times 1/2 to the T over 4. And I can just plug stuff in. 6 weeks, 42 days. Shouldn't be a problem. And you don't know what 42 over 4 is, it's cool. Calculator will figure it out for you. 64 times a half to the 21 over 2. And I'm good with 4 decimals. Sorry, you can't see my calculator. I'm good with 4 decimals. 0.0442. You know, when you take your physics classes and your chemistry classes, they'll tell you how many significant figures to round to, right? I remember 3 in high school. That's what I remember. That was back in the day. 13. A wooden artifact from an ancient tomb contains. This problem is just so poorly written. Let's go with 20% of the carbon-14 that is present in living trees. How long ago to the nearest year was the artifact made? And the half-life of carbon-14 is 5730. You don't have to use PERT. You don't. You can use the straight-up half-life formula. And then just throw stuff in it. So we contain 20% now. We were 100 when we existed. I don't know the time, but I know the half-life is 5730. And from there, you're just going to ln. You're going to divide out your 100 and get a 2. So 2 is, I don't know why I said 2. You're going to get 0.2 or a fifth, whatever you like. I'm so tired, I'm just going to write 0.2. ln both sides. And hopefully you realize that you have to multiply both sides by 5730. Yeah, I kind of wrote that where it looks like it's in the divisor. I have to multiply both sides by 5730. And I have to divide by the natural log of a half. That is my time. How old is this thing? And remember, I changed the context of the problem because there's no way I'm going to make you do 50% because then it would just be 5730. Oh, yeah, I am so tired. I'm ready to go home. 2,468 years or so. It's negative because it's, to the left. You think about plotting time on the XY axis. But it's 2,468 years roughly. So old, right? Here we have the doubling period of a bacterial population. It's 10 minutes. There's some shortcuts to this. If halving uses a half, then doubling would use it too. So you can actually use that the amount after time passes is the principal times a 2 to the t over the double time, which I'll just call dt, the doubling time. It's just a shortcut. If you don't like that, use figure it out. Use principal times 1 plus r to the t and just go with it. If you use that, your rate of increase is 100%. But anyways, you do you, I'll do me. I'm going to use this little shortcut guy. What do I know? At 110 minutes, there's 90,000 of these little guys. So 90,000 is my principal times 2 times 110 over the doubling time 10. So 90,000 is my principal times 2, which is raised to what, the 11th power? Once upon a time, I used to know that. Today is not the day. It'd be 32 times 32 times 2. So 32 times 64. 2048 maybe? 2048. 90,000 is 2048 p. And we'll just divide by 2048. These are life forms, so the initial amount present is 44. There were 44 of these dudes. Okay, we have to round them up. There's no way you could have 94 hundredths of a bacteria. So 44, cool. Now the amount after time passes is 44 times 2 raised to the t over 10. 5 hours is going to be what, 300 minutes? I believe. There ought to be a whole bunch of these little guys by then. 300 over 10, 30. Bunch of them. Wow. That's a lot. 4.724 times 10 to the 10th. I don't even think there's enough decimal places here. I can only move 9. Bunch of them. So 4.724 times 10 to the 10th power. Crazy, huh? Whole bunch of them. And that sadly was the bell, but the good news is I actually finished everything. I might look back at some previous ones that I was struggling with earlier. It just depends if I can wake up or not. If I can't wake up, I don't have it in me right now. I'm trying.